everyone, and welcome back to another episode of the Teen Talk Show. It's 6:30 a.m. here in India, but it's a bright morning for technology. In today's rapidly changing world, many teens are grappling with the big question: will AI take away our jobs? With the rise of artificial intelligence, there's a growing concern about what the future holds for us in our careers of various fields. To help us address these important questions, we are thrilled to have Tanmay Bakshi here with us today. Tanmay is not just a prodigy in AI, but a global thought leader who understands the impact of technology on our lives and our future. Along with Tanmay, we also have an incredible group of curious teens joining us today from diverse career fields, including medicine, industrial design, and business. They are ready with some thought provoking questions about AI, its impact on the future, and how we all can prepare for what's ahead.
Hi, everyone. Good morning.
Tanmay, it's an honor to have you with us. We'd love to start by sharing a little bit about yourself.
Hi, Manju. Thank you very much for having me today. I'm really excited to get to share my journey and have a discussion around the world of tech. First of all, to share a little bit about myself. Of course, my name is Tanmay. I love the world of technology. It's something that I've been passionate about for quite literally as long as I can remember. I got into the world of tech at first, something like 15, 16 years ago, back when I was 5 years old. And initially, it was mostly just curiosity, right? I mean, as a 5-year-old, I'm curious about everything, curious about the world. But in particular, technology was really fascinating to me because it was so much more interactive than everything else. Like it felt like a computer could do so much. And my dad used to work in software development. And so watching him code all day was also really fascinating to me. And so I wanted to learn more. That's how my curiosity started. And it really just continued to snowball every time one of my questions would be answered. I started to use the internet and different books as learning resources. As a matter of fact, at one point, I had a test coming up at school for which I had to practice my times tables. And I thought, what better way to do it than to create a little application to help me practice by just asking me random questions and seeing if I get it right. And so I did that and then realized, hey, like this was helpful for me. Why not make it so that other people can use this app too and benefit from it as well? And that's when I published my first iOS app to the App Store back when I was around 9 years old, which was a really exciting experience. And since then, not only have I been super passionate about creating technology that helps solve problems for people, but also sharing whatever I learn about the world of tech to really give people the skills to answer their questions around how they can use tech to solve problems they see as well. Through resources like my YouTube channel called Tanmay Teaches, through the tech books that I've authored, through the keynotes and the workshops that I do at conferences all across the globe. It really is something that I find really fun. And working towards my goal of reaching out to and helping at least 100,000 aspiring coders to help them innovate along their journey of learning to code. And I think that's really exciting. So that's a little bit about me. In particular, these days, I'm really passionate about the world of AI technology and ML, and I'm sure we're going to dive deeper into that today. So yeah, that's a little bit about me and what I do.
Now, to kick things off, we would like to start with a question. And we have a question from a teen who lives in Norway. And his question is:
Hi Tamne, my name is Aaron and I'm from Norway and I have some questions for you. Some of my questions are: what language should one learn who's trying to get into IT? And other question is: which field is more beneficial within IT? Is it front-end development or back-end development, or like testing or QA testers, like, or data analyst? And how do you prepare and create a awesome CV in a way? Do you do a bunch of lead code questions? Do you do certifications? Do you make tons of projects? And like generally, how can you try to get into this field as a new person? Thank you.
Right. That's a great question. I'm happy to dive into that. So thanks for the question, Aaron. I mean, first of all, what I'll start off by saying is that personally, I'm not the biggest fan of the way that recruitment and like hiring generally works for companies. I think the process is a little bit skewed because it's not really optimizing for finding people with necessarily the best skills. A lot of the times, unfortunately, the way that recruitment works for companies is it's usually optimized for scale, right? And I say that as someone who's actually had to go through the process process in terms of like hiring people. Like I'm actually currently actively hiring for the team that I'm working on at IBM right now, and it is really challenging to solve this problem. But I think there is a way that candidates can make it clearer what their skill set actually is, what they're passionate about, and also that recruiters can try and find the people who really are experts in, or even not even necessarily experts, but people who are actually really passionate about the domain that they are entering or have already entered. And I want to start off by saying that in terms of specific skill sets or specific, I guess, domains to enter, I'd say that my main advice there would be not to go off of what I say here, because it should be based off of what you're passionate about, right? What you decide to learn and what you decide to specialize in should be based off of what you believe is most exciting to you. And first of all, I say that because obviously there's the cliche around people who really love what they do or really good at it. But I think there's actually a lot of truth to that claim. And I've been thinking a lot lately about why that pattern usually exists, because I've seen it myself. A lot of people who are best at working with technology that I know are the people who genuinely just love it. And I used to think that one of the reasons for that would be because if you love it, then you just end up spending so much more time with it, and you just end up getting so much more experience that it makes sense that you would become a lot more familiar with the concepts and be able to work with it well. But I'm starting to realize now, I think there are also some more reasons behind why people who love what they do are really good at what they do. And it ties exactly into what I also believe you should aim to do in terms of your process of learning and also demonstrating what you learn. And that is performing or really honing in your skill of what's called abductive reasoning. And abductive reasoning is a process of taking a set of observations generally and trying to distill what sort of properties or rules of a system would result in those observations, which is, a little bit too, I guess, technical mathematical, but like bringing that back to what that means for the real world, what I've almost caught myself doing, just instinctively, it's something that I just do whenever I'm like using a computer or using technology, is I like to think about, when I'm interacting with a piece of tech, why would it work the way that it does? Like the other day, for example, I found a simple bug in one of the beta macOS versions. Like I'm currently on a beta macOS, and I found a simple bug when it comes to screen mirroring. And immediately, just without me thinking about it consciously, the first thing that comes to my head is like, how could they have implemented this feature that would result in them being able to make a mistake that would result in this bug being observed, right? And that's something that I genuinely just do because I'm curious about it, because it's interesting to me that that sort of issue would be something you'd encounter. And I find that really the people who are best at what they do are the ones that have really honed in that ability to perform abductive reasoning naturally, because these are the sorts of people that seem to just have the answers to all sorts of questions that you wouldn't expect them to. And it's not because they have the answers, it's because they don't take things at face value. They sort of understand the underlying primitives of the systems that they're working with. And so when you ask them a question they haven't thought about before, they're able to recompose those primitives into a new answer, making it look like they knew the answer, but really it's just, you're coming up with the answer on the fly because you understand those core constructs. So what I'd say is if you are able to experiment with a lot of different fields, a lot of different domains, and if you're able to try out a bunch of different, even just, parts of technology, things like backend development or DevOps and so on, what that does is it gives you that initial sort of, getting your toes wet experience of just feeling what the domain is like. And if you enjoy it, I find that generally you will be curious enough to try and answer the question of like why? Why does something behave a certain way and so on? And when you keep digging deeper and deeper into why, and you try and understand the, basics of systems and how that results in the tools emerging that you use every single day, then I find that you become really, really good at what you do. And especially in actual job interviews, that becomes really obvious to recruiters, I find. At least to me, it definitely is. And so I would definitely say that from the standpoint of your CV, the way you can make it stand out is by having a lot of just real world applications you've built. I've always said that the best way to learn things is to build things yourself. It doesn't matter if it's what you might consider like a toy example or a real application, or it doesn't need to be complex. Just the fact that you've built things and that you're able to explain like the mechanisms that actually power those things in detail. You're able to cover, I guess, the inner constructs of that system without using buzzwords, I find, is what really sets apart the people who really understand those systems versus the ones who have just, built with them. So I'd say get a lot of experience with a bunch of different domains, find what you're passionate about, take what it is that you're passionate about, and then go and build real world projects. Come up with random toy examples, build them, put them on GitHub, put those in your CV, and then in actual job interviews, make sure that you are sort of, I guess, actually trying to steer away from a lot of the hype and the buzzwords around technology and focusing really on taking whatever scenarios you might be presented with and trying to leverage not just the immediate tools that you have, but the constructs behind those tools to try and think of like novel solutions to problems. Like with LeetCode, for example, oftentimes LeetCode and HackerRank, these resources are used as an initial way of like filtering and screening through candidates, which is why sometimes it is necessary to like optimize for LeetCode and become really good at these sorts of problems. But it's not just about that. It's all about instead getting, once again, those core sets of constructs really strong, because then you're not just good at LeetCode, you're good at software in general, right? And so I think that's the best way to scale it, which is kind of high level, but I think truly building real world code is the only way you get real expertise, because you feel almost the pain of your mistakes when you make them. And you think, 2 weeks ago when I wrote code this way, I should have actually written it this other way because then I wouldn't be facing this right now, right? So actually feeling that is what gives you the expertise of why you should do things certain ways. So I think that's honestly probably the best general path to take. But of course, happy to dive into detail on any more part of this if we'd like.
In your one interview on Tech Talk, you mentioned that you have a friend circle ranges between 50 to 70 years of age. So here I want to know that what are the common interests do you find in them that you had like them to make your friends, or you are just too extrovert that you love to make friends?
I mean, first of all, thank you. That's actually a great question. And I mean, honestly, I think you can really make friends with anyone that you have some sort of common, I guess, interest or some sort of, I guess, thing to start that relationship with, I find. Now, to be honest, as you probably can tell, I love technology, and so a lot of my friends, the way I met them or the way I ended up becoming friends with them usually boils down to some sort of technology. Not necessarily always, but that's generally a common thread. And I will say that for that particular range you were talking about, for like 15 to 70, the youngest and the oldest members of that range are definitely relationships that I formed while working on technology. As a matter of fact, I remember that I believe one of my oldest friends is someone who I worked with initially when he reached out to me a few years ago to ask for some help on some code he was writing for an application to help the handicapped speak through text-to-speech technology, and I was helping him out, and that's sort of how that started. And even I believe one of the youngest friends that I have was actually helping them out with an assignment that they had for one of their high school computer science classes, and that was through one of my other mutual friends that I met at IBM. And so it's really a network. I mean, first of all, I do love to make friends. I think that generally humans, like, what sets us apart is our ability to collaborate and work with people. So generally, I love the ability for people to work together. I think that's really interesting. And so I love to, make friends, collaborate with people. That is a fun sort of experience for me. And yeah, I think really you can make friends with whoever you want to, as long as there's some sort of common thread, and everybody seems to love technology and building with it. So everybody who I find like tries working with it eventually ends up loving that experience. And so that's how I make these friends, and it's been a really fun experience.
That's cool then.
Thank you.
Well, you have started coding at a very young age, and you have become successful at a very you at youth age also. So I have, just like you said, that you have generated curiosity there by watching your father doing coding and etc. But not like you. I have no background in coding, so my parents didn't know much about the coding. So if someone like me who has just started his career in coding, so can you? Is there any specific strategy or method by using which a beginner can learn coding effectively at a very less time? So is there specific strategy that you have also followed and you want to give your suggestions to others also? Please share.
So I will say that with, I think, any skill, especially technology, especially code, because code is effectively just problem solving, but with logic and computers, right? I find that the amount of experience and knowledge you can gain is sort of like a snowball effect, where the more experience you have, the quicker it is for you to gain even more experience. And so, unfortunately, one of the results of that is that while maybe like a year or two from now, that's going to be a really good thing, at first, it's going to be a little bit of a bad thing because that means that at first that snowball starts smaller, right? And so it takes a little bit more time to gain what you might consider a little bit of experience. So, I mean, in terms of like spending time, I think the fact that some time is spent is necessary is just unavoidable. But in general, the way that I like to go about it, which isn't necessarily the best way to start for a beginner, but I'll get to that in just a second. The way that I like to go about it is by taking whatever it is that I'm learning whatever new thing I want to learn and trying to relate it to whatever I already know to see what the differences are. In fact, if anything, this goes a little bit back to the sort of abductive reasoning that I was talking about. Because if you think about it, like I'll give you a real example. Recently, I was trying to learn JAX, which is a new machine learning framework. Well, it's not new, but it's relatively new compared to a lot of the other ones. And before this, I had most experience with PyTorch, which is the most popular machine learning framework out there. And when I started learning about it, sort of if you think about both of them being effectively the same, I guess, kind of framework, they both have the same kind of goal. That means that I would imagine that a lot of their feature set is probably very similar. And when there are differences in their feature sets, then those differences would most likely arise from differences in the very core constructs that build those systems. Like PyTorch, for example, is like eager execution, they run your operations right away, whereas JAX is different. JAX can do that, but the idea behind JAX is really that you want to ahead of time figure out all your operations, construct a graph, and then run them, right? And so even though I knew about that difference beforehand, even if I didn't know, I would have very easily been able to figure that out if my approach was, okay, let's take a look at the differences between the way these two things behave, realize that there's a reason there would be differences, and then try and figure out why those differences exist. And that brings you down to those core constructs pretty quickly, I find. That's like a general strategy, and applying that from a beginner standpoint, the way you can probably do it is take, whatever experience you gain and use it to try and sort of infer what other parts of like a programming language or a framework or a tool might behave like before you actually get there. A common example that I like to point out is well, not recently, I guess 4 years ago. I learned the Rust programming language, which had been something I'd wanted to do for a while, and it was really fun. I enjoyed learning it, and for the past like year and a half or so, it's surprisingly common how many times me or one of my friends will write some Rust code, and when we compile the code to try and see if we'll get an error or if it'll work, we find that usually it works, but then sometimes when we haven't actually made a mistake, but it doesn't work, we actually see an error message where it's like, oh, the feature that you're trying to use is actually still under development, and here's the GitHub issue where we're trying to add that to the language. And so it's like we basically wrote code for a feature that we thought Rust should have based off of all the other features it has. And not only were we basically right in assuming that it should have that feature, but they're actively working on adding it. We just didn't know it didn't exist yet, right? And so that's the sort of inference you can make about programming languages and everything when you sort of boil them down once again to their core constructs. And so there now exist, and sort of going back to the JAX example I was sharing a moment ago, there now exist all kinds of brand new tools that didn't exist just a few years ago, like ChatGPT, AI tools, these sorts of things that can help you create these sorts of personalized comparisons, walkthroughs, guides very quickly for you to go through, and then help you sort of get a head start, like a quick start, to building your own little examples to gain that experience. So I think taking whatever experience you do have and trying to use that experience to make assumptions and inferences about how you might be able to do more complex things, trying them out, seeing where you're wrong, and using where you're wrong to challenge your assumptions about why you shouldn't have been able to infer that behavior, I think is probably a really effective way of getting started and learning more. And of course, leveraging new tools that previously just didn't exist. Like with the Jax PyTorch example, I quite literally asked ChatGPT, like, hey, write a simple example application that does iris flower classification, PyTorch and Jax, so I can see what the differences would be. When I was learning Kotlin, a programming language, or Dart, actually, when I was learning Dart, I told ChatGPT, hey, write, maybe 20 different examples of simple algorithms with a paired implementation, one in Swift, one in Kotlin, so I can take a look at the differences and figure out how things are done in either language. Obviously, that's not perfect. There's still some things that might miss, but that's a really great way to start, I think. So that's what I'd say at a high level for getting started.
That's incredible, Tanmay.
Hi, Tanmay. I'm
Hello.
Gatik from Mumbai, grade 11. My question to you is that in 3 to 5 years, do you think that coding will be still as relevant as it is today, or will AI make traditional coding less important or redundant? How should teens adapt to these changes, and how they can improve themselves with the changes that are going right now?
I think my answer to the first bit there, and this is a really, really interesting, I guess, rabbit hole to dive down. There's a lot of different opinions about this. But my answer to the first bit, will coding still be relevant, is 100% yes. Like I would definitely say coding will still be relevant and we're not being replaced by AI. But I think it will definitely change the sort of landscape of what it means to do software development. I mean, even in the past couple of years, like the past decade or so, there's been a big shift in I guess the general skill set of like an average software developer. And a lot of folks that are more traditional and have been coding for like decades, a lot of them might complain, and there's sort of the stereotype of older developers complaining about younger developers not really knowing much and being too high level. But I would say it's not necessarily that developers have gotten less skilled over time. That's not the case. I think developers' skill sets have shifted to being at a higher level, which is necessary because we want to scale the number of like outcomes we can deliver through businesses, through applications, through communities. And to do that, we need higher levels of abstraction, making it easier for more people to build out systems that do things. And so that's like this is a natural progression of technology. I think that's a good thing. And there's still a place and a role for people to do lower level development because we haven't invented the perfect computer yet, and we never will. There's always the evolution. But then from there, there's now in sort of the existence of higher performance computers and higher level programming languages carved out a new space for developers that don't know anything about the lower level of technology, but are still able to be productive and deliver interesting things and useful things. So I think with the addition of AI to this space, that does a few things. That first of all lowers a barrier of entry to both of those existing, I guess, sub fields, but then also adds this whole other section of developers that couldn't have existed before, where you have an even higher level understanding of the technology that you're working with, but you're still able to be productive with it and deliver things. It's just that fundamentally, as you get higher and higher in the stack, sort of what sorts of things you can deliver becomes narrower, narrower, narrower. And AI, I think, right now is really good at giving people the illusion of not being narrow, but it is still narrow. It's still stats at the end of the day. It's just that how narrow it is, it's getting slightly broader, and also how accurate it is at being narrow is also getting better and better. It's becoming more reliable, is what it is. So I think it'll definitely carve out a new space for a new kind of developer that couldn't exist before. It'll make existing developers more productive significantly. But at the end of the day, I don't think this technology is replacing humans, and we could go into more detail about that. But I don't see the fundamental techniques and technologies being used to develop these machine learning algorithms being able to reach the kind of like AGI or human level creativity that we seem to have. So that's the high level view of it. But overall, coding is still going to be relevant, and I would definitely recommend diving into the world of technology because AI is only going to make you more productive at it in the future.
Then one last question from my
For sure.
side. I would like to quote one of your lines that truly made me mesmerized. It being most simple and the most common thing. You said it in your IBM interviews. A computer's power is not with natural language, it's with math. A human is better at talking to people. Then, do you find that the power of the universe, maths, can help AI to develop human emotions rather than replicating it by constructing its own unique identity, by seamlessly merging into the human society and being another subspecies altogether, having same relationships as humans?
that is a great call out. Thank you for bringing that one up. That's one of my
Thank
I
you,
guess
Tanmay.
classic quotes from a few years ago. But I that was a that I think math is very interesting because I, for a long time, have wondered how to think about the role of math in a lot of different, not just machine learning, but also what math, I guess, conceptually represents. Like, for example, there's the whole debate around was math discovered or invented, right? Was math discovered as like a system that is just universally true, or did we invent a specific way of performing mathematics? But theoretically, say like aliens could have a completely different way of doing it that's completely unrecognizable, but still internally consistent and valid and allows them to model things. And it's an interesting conceptual discussion, I think, like if, even just a philosophical one. But I think what is interesting about the modern AI technology that we have is that it effectively proves the existence of certain behaviors of math that we couldn't have proven before because we simply didn't have the computing power and the data scales to try and prove it. Like if you go back in time, many years, and you take a look at the original paper where Alan Turing sort of proposed the Turing test, which is now like the standard of how we try and measure like is a computer intelligent. You realize that his original methodology was, you've got person A, person B, and you've got an interrogator, and they communicate with each other. So the interrogator can ask each person questions and get answers, and they have to communicate in written language using typewritten like notes. And the reason that Turing devised it this way is because his idea was that language is sort of the purest form we can get to of just human thought and sort of detaching that from the way humans behave physically. And so the idea is that the interrogator asks questions to person A and person B and tries to figure out who is A and who is B based off of the answers. And the people are trying to trick the interrogator into thinking they're the other person. Now, if you have the interrogator do this for long enough, you can determine an approximate percentage of accuracy for this interrogator. And if you swap out one of the people with a computer and you don't tell the interrogator that you did that, and if the interrogator's accuracy stays the same, so they're still behaving the same way, the idea is that that computer's intelligent because they're behaving the same way a human would, and therefore the interrogator's performance was the same as it would have been otherwise with a person still responding. But now we take a look at modern AI technology, and you realize that, for example, with GPT, especially the GPT series of models, we've now proven that, well, computers can actually start to use language so well that they can usually trick humans into thinking that the language was itself human generated. So would you say that humans are, or the computers are generally intelligent by, definition of the Turing test? Well, I still wouldn't say so. But at the same time, back when Turing wrote this paper, there's no way we could have possibly known that if you just take a really large statistical model and you throw a bunch of text at it from the internet, which itself didn't exist at the time, right? That we'd be able to get these models that are really good at giving us the illusion of intelligence. And this is an emergent property of mathematical models that exist in dimensional spaces that are thousands large, right? Like these are thousands dimensional large internal spaces where we're representing concepts. And just not only is it unfathomable for us to even like visualize these spaces, like that's like it's laughable to try and visualize a 1,000 dimensional space. They're directions that you can't conceptualize. But the fact that we are now able to take the math behind machine learning and run it through all this data to try and find these emergent behaviors is really fascinating. So I think that we have definitely learned a lot in machine learning in the past few years about the nature of language and the nature of intelligence and the fact that there is a pretty significant portion of it, or at least a not insignificant portion of it, that can be represented just through mathematical statistical learning. And I would say that the nature of it means that fundamentally these models don't really have necessarily what we would consider an identity in the classical sense, but that might just be what we need to almost redefine what we think of as an identity, if that makes sense. For example, like one of the main reasons that in a lot of use cases we might not be able to replace humans with AI, which is a good thing, is even just accountability, right? When it makes a mistake, who's accountable for that mistake? If humans are responsible for reviewing things every step of the way, you actually have people that you can hold accountable for mistakes and for ensuring that processes evolve and change based off of new scenarios. But when it's, ML, it's stats, it's data distributions. When something unprecedented happens, they're not going to be able to deal with it, and whose responsibility is that? And so similarly, if that's like the classic definition that we're going with, then these AI models don't really have identity in the classical sense because they are fundamentally just parameters that have been tuned by calculus on top of a bunch of internet data. But the emergent behavior of that system makes us as humans think of them as having an identity because we're biased to thinking that entities that communicate with language have identity because for tens of thousands of years, the only entities that could use language were humans. And so the human brain is obviously very biased to thinking language equals intelligence equals human. That's one thing in our heads when realistically now there's a third thing or a second thing that's not human and isn't really intelligent but does use language really well. And so it's a very nuanced answer, I think. There's no like universal true answer here. And what will happen next is really anybody's guess. I could be wrong. Potentially machine learning does lead to AGI in the future. But from all the evidence that we've seen so far, I'd say that this track of development won't lead us there. And there is definitely still a role for humans. And I think society itself will just evolve to seeing these things more as tools than as like mini humans almost, I think. And so they will gel with us into society and help us perform tasks and things, but as tools, I think.
Thanks a lot, Tanmay.
Of course. Thank you.
Hi Tanmay, my name is Sanjeevni. I am a grade 12 student and I'm currently studying in Jammu. I was going through some of your videos where you mentioned the intersection of AI and healthcare. I wanted to ask this. As someone who has achieved so much at a young age, what inspired you to explore the intersection of AI and healthcare? And what advice you would give to someone aspiring to follow a similar path?
Thank you very much. That's a very interesting field, and I appreciate that you brought that up because healthcare is definitely one of the domains that I've really loved getting into for many years now. And I think one of the main reasons for it is because actually there's two main reasons. One of them is I think more obvious, and that is the fact that there's such a direct and obvious immediate impact to human life. Right. So even thinking about some of the simpler applications, right? Like if you were an Apple Watch, like I have an Apple Watch, that means that almost all the time, every hour of the day, my heartbeat is being monitored for arrhythmia, and that gives you a sense of confidence of there's machine learning models actively checking my heartbeat to see if I have an arrhythmia, and it'll notify me if something's wrong, or if I take a fall, right? It's based off the sensor data. It'll detect if I took a fall, and if I don't respond, it'll automatically call emergency services for me, right? Like these are things that give you confidence, and they're things that actually have an impact on people's lives. They've saved lives, and the ability to just ship technology that at scale can help so many people live healthier lives is just, I think, incredible. So I think that first of all, there's a big impact to human life, and that's really interesting. But also, one of the reasons that I think machine learning in healthcare is particularly interesting is because of the fact that machine learning is, if you think about it, one of the most universally applicable technologies. Because at the end of the day, ML is all about finding patterns in data. It's about being able to build mathematical models that accurately describe data. And so if you have data, then you can use ML, is what that means. And so every domain has data means you can use it in every domain. And so AI tech developed for healthcare is basically instantly applicable in a lot of other domains, and similarly the other way around. A simple example is, I was working, think something like a year and a half, 2 years ago, on a project around automating the McDonald's drive-through with machine learning, which was a fun project. I loved that one. But not just because I could finally combine tech and fast food, but also because I was able to then take those architectures and they will now actively be applied to conversational agents in other domains, like for example in like education and healthcare and HR and so many other places. And so the core technology constructs scale and can be used across domains. So the fact that healthcare data exists in such vast quantities and is basically going untapped right now, but could have such a big impact on human lives, and that the technology is still innovated from a tech standpoint, regardless of domain, means that I think healthcare is a great place to even just start this innovation because it trickles into other domains and it starts with healthcare, which is like a great way to make impact. So that's really what drew me to the world of using AI with healthcare. And getting into it, I think healthcare is unfortunately one of the more difficult domains to like get into because it's so sensitive. There's so many data access control issues. There's privacy problems. You have to think a lot about bias, making sure that things are actually medically accurate. For example, even Apple Watch arrhythmia. That was actually kind of controversial with doctors because they said that, hey, when the Apple Watch misreports and accidentally says someone has arrhythmia when they don't, this is stressing the hospital system. So overall, you could potentially say this is having a worse effect on people's health. And so, there's all sorts of different arguments to consider and lots of little nuance to take into account. Overall, though, these days I find the field is more approachable than it used to be. For example, there's PhysioNet, there's Kaggle, a bunch of other sorts of places where you can go to grab data sets that are healthcare relevant. You can instantly download hundreds of thousands of like electrocardiogram ECG recordings to use for diagnosis and building your own ML models and getting experience with that. So I think there's a lot of interesting potential for applying AI in healthcare. And I would recommend really getting strong software architecture foundations because that's especially important with healthcare, making sure that you can actually scale your applications and build them securely. Being able to get really strong machine learning foundations in general, not even necessarily specific to healthcare. And then really trying to understand the domain of healthcare itself better and how people work can also help you a lot when it comes to determining where to apply machine learning in healthcare. So that's what I'd say is probably the best way to get started, and why I love working with AI in the field of healthcare.
Well, that's an inspiring answer.
If you had to envision healthcare 5 years from now powered by AI, what would it look like and how can students like me prepare to contribute to that vision?
I would say my vision would be open access to larger and more complex healthcare data sets, as well as more advanced ways of actually measuring this data on the edge. And I'll explain what that means in a moment. And putting machine learning models on the edge as well. So what that means is, like, for example, right now with the Apple Watch, I already talked about the fact that they're already collecting your accelerometer and gyroscope data, so like your movement, your heart rate, your electrocardiogram. They're collecting all this data and they're using it actively for healthcare outcomes. But I think that right now there still needs to be a lot of work done on the physical hardware aspect of being able to put more complex sensors to get more body information and other kinds of info that can be used for more advanced diagnostic purposes, as well as putting enough compute power in these devices to allow them to actually perform that kind of inference. For example, for years, there's been rumors about Apple Watch being able to do things like detect blood sugar or even blood pressure and so on. But to be able to do so requires fundamental innovations at the hardware and software levels and the algorithms to do that before we even start to get to the machine learning and the diagnosis pieces. Right. So right now, I would say that unfortunately, a lot of the blockers in the world of applying AI to healthcare aren't actually in even necessarily the ML and the data. It's just in the hardware. Because while in an actual hospital, you might be able to get all the data necessary and run it through your models, where people actually are, which is just in their everyday lives, it's hard to collect all that data consistently and then actually use it for diagnostic purposes. So I think my sort of future vision is the ability for us to have significantly more advanced data collection on the edge, just continuously and passively on people, being able to use it continuously for sort of like passive diagnostic purposes like the Apple Watch does right now, and then being able to scale the way that we collect and anonymize this data, potentially using new techniques like homomorphic encryption, these sorts of things that I've been meaning to learn more about, and then taking that open access data and enabling people to just sort of like go crazy with that data and build all sorts of interesting applications with it to see which ones would eventually trickle down into production applications that actually help people. I think that is really my vision, and to work towards it, we require innovation on every front, which goes back to what I was saying around choosing what it is that you're passionate about doing. There's no wrong answer. There's no wrong answer as to how to contribute to this vision. If you're working on more efficient machine learning models that can run on low power devices, that's helping. If you're working on trying to answer some of the like mechanical hardware issues around how to measure blood pressure with a watch band. That's helping those sorts of things. So yeah, there really is no wrong answer. Universally throughout this pipeline, the contributions stack together to work towards solutions. But I would say that yeah, generally the biggest bottleneck right now does seem to be hardware and being able to collect and scale the process of the collection of healthcare data.
Thank you, Tanmay. That was an inspiring answer again. Thank you.
Thank you.
Hi, Tanmay sir. My name is Ronak and I am from J&K, India. So my question to you is that do you see yourself designing the next big sports car or figuring out how to make flying cars a reality?
So that's a really interesting question because a lot of my friends are into like cars and those sorts of things. And they don't really respect my opinion on cars because my answers to their questions are usually I want something that is electric, silent, and drives itself. Uh, so I mean, first of all, it's not that I don't like the technology behind cars and that sort of thing. It's not that I don't think it's fun. It's just that I think that the other side of things is even more interesting and fun for me, which is the actual like technology behind the cars, not the cars themselves necessarily. So I would say that I definitely can imagine working on, automobile related technology. Again, ML's universal applicability means that a lot of what I do transfers over pretty easily. But like for example, one of the things that I always say is that eventually I want to get like a Tesla because it's just interesting to me to watch that full self-driving technology operate. I remember a little while ago I was working on a chess bot, and one of the things that I found like weirdly enjoyable to do was even just like watch this bot play the game to see the way that it goes through its like decision-making process, like seeing these systems that you build, machine learning systems especially, since they're so complex, just watching them engage in behavior is interesting because they're doing things that typically are considered human. And so I think car technology does definitely interest me a lot, especially because of machine learning. But I wouldn't say I'm necessarily as deep into the car world as a lot of my friends are. But definitely fascinating technology regardless. It is exciting.
Hello, Tanmay. I'm Sahaj, a grade 10 student from Kashmir. And my question to you is that how can teens from small towns like me start actually developing in AI in simple and affordable ways?
Mhm,
Because here we still face problems like power outages and low bandwidth.
mhm. That's a good that's a problem that I've been thinking a lot about actually recently. And the reason is because it's even for people with access to like relatively a lot of resources, even for them, AI has become a lot less accessible than it was a few years ago, which is becoming a big problem. You see, for example, Microsoft and OpenAI have started investing not in AI ML software, not in building data centers or hardware and infrastructure. They've now had to start investing in the companies that will build the power plants to power the data centers they will build for the hardware that will be invented for the machine learning technology of the future. So it's like we've gotten to the level of physically running out of enough power in like the US grid to power a lot of these data centers for machine learning. That's how massive these models have gotten. And so the fact that we've sort of and this also goes back to what I was saying about what we've learned about the nature of data and intelligence too. The fact that we've almost not necessarily given up, that's the wrong word, but the fact that we've defaulted now to our solution to a lot of problems being scale instead of more intelligent solutions, or specialized solutions, principled ones, means that AI technology is getting less accessible as a whole, unfortunately, than it used to be. However, what I will say is that keep in mind that even before a lot of the modern AI tech existed that relies purely on scale, before that, ML was actually surprisingly democratized as a technology. Like for example, access to resources like Google Colab makes it so that even with low bandwidth on your own machine physically, or even if you might experience power outages or you don't have access to like a GPU, you can still get at least a reasonably sized GPU for free that will last beyond maybe like network outages immediately for yourself, and the servers they're running on have decent bandwidth, so you're able to like download things on them pretty quickly, download data sets, and do your ML tasks. So keep in mind that even before the advent of the kinds of ML technology that rely on scale, there was a lot of ML that was accessible and was really important to sort of like build those foundational skills and even to build real world applications too. And the advent of the new ML doesn't make that old stuff not useful. It just means that there's a new class of capabilities that you could work on. It's just that unfortunately those require access to a lot more resources than most of us would have. Even I, like, in my day to day, even at companies like IBM, like sometimes it can be hard to find the resources to train models just because there physically sometimes aren't enough machines to use for all of us. And so I would say that it is a problem, but don't necessarily focus too hard on the new and shiny ML that is purely dependent on scale. Take a look at some of the classic techniques. Think about the way that AI was built, maybe 2 or 3 years ago, and learn from the ground up because there are resources, as I mentioned, like Google Colab, Kaggle notebooks, cognitive class labs, all these sorts of places where you can go to get these resources and start training ML models yourself for free. So I'd say that's a good way to get started. And then there's also good ways to incrementally get deeper into this. So for example, maybe Colab isn't quite enough for you, and then you can start paying for like maybe a Colab Pro subscription where it's not so expensive that you're basically buying a GPU or getting a cloud instance, but it's also quite a few more resources than you would get just using the free version of Colab. That's something that you can get as sort of like a next step. And so I'd say there's definitely still ways to do it. It is a bit more challenging, and I think that's one thing that the AI field has to really start reining back in is making models more accessible and trying to focus on more principled solutions to problems instead of saying bigger models. So I think that's something we need to work on as an industry. But overall, there's still ways to get started. There are resources you can use, and I think it is still definitely doable.
Yeah, thank you so much. And my another question is that how important is networking in tech world, and how do we actually start networking when we are in school itself?
Mhm. I think networking. I mean, there's the common phrase everyone's heard, of course. It's not what you know, it's who you know, which is kind of an unfortunate phrase. And I would say that it's not it's definitely not fully true. Like what you know is it definitely matters. But it's also unfortunately not fully untrue. Reasons for which it can be untrue. One of the reasons is just, sometimes there's just nepotism involved, where there's people that know people and will just keep working with those people. And that's not really that's not the greatest. That's always an unfortunate situation where, the only reason that, for example, someone might get a certain job is because they know the right person. But I also find that a lot of the times, the reason that networking can be important is not necessarily just to have a connection that can help you do things, but to help people get a good intuitive understanding, like a really good understanding of exactly what your skill set is. Because I find that one of the hardest things for me, even when I'm recruiting folks for my teams and things like this, one of the hardest things to really understand is just from interviews and stuff to really get a sense of how do you go about the process of solving a problem. What things have you had experience with? What sorts of problems would you likely be able to have prior experience with, despite me not knowing if you've had it? Those are things that I would get a much better understanding for if I've worked with you for a couple of years. And at that point, even if I know that, like, on paper or even, based off experience, you're equally as qualified as someone else, I would choose to work with you because I'd be able to work with you more effectively. I'd be able to give you problems I know you'd be able to solve well and help you structure them in a certain way that makes you more effective at them. And so I think networking's importance, you should approach it not from the standpoint of making sure you know the right people and have the right relationships, even necessarily. That's important, but making sure that you have the right relationships with people who are able to get a good understanding for the way you work and the kinds of problems you can solve and the kind of experience you have. And also the other way around. You also want to gain a good understanding of how other people work so that you can tap into that network as well into the future. And so I think really trying to optimize for getting a good understanding of skill sets and sort of that sort of thing is key. But then also being able to present yourself in a way to people that gives them a better picture of your skill set and your expertise from the get-go without needing to have that sort of connection goes a long way in sort of reducing the amount of impact that just pure networking has on your sort of career outcomes. And that goes once again back to what I was saying in the beginning around, really understanding the core constructs. I find that, I always try and I always try and work with people that have that sort of deep understanding of core constructs, because then they can compose them into novel solutions that they never would have had experience with before. And so you can do this sort of thing. You can get more experience for how to present yourself that way through online meetups, things like meetup.com. There are virtual ones you can join. There's ones in person, of course, that you can go to. There's community events, like for example, I've done a couple talks over the past few weeks and months at different Google developer groups, where at different universities and colleges they'll bring together the student community and hold events every couple months around different technologies and so on. They'll bring in different speakers, and the internet is your friend here. The internet helps you connect with everyone in the world, right? And so you can use platforms like LinkedIn, even GitHub, Stack Overflow, and so on to help yourself find people with similar interests or with knowledge in certain domains. For example, maybe one of the things you choose to do to get some experience or to put on your CV is to build simple applications and put them on GitHub, or to contribute to existing open source projects. And when you contribute to existing open source projects, there are people that will work with you as the maintainers of these repos and so on, that you can start to network with and build a relationship with if you become maybe like an active contributor to the repo, that sort of thing. There's also platforms like Discord, where you can join these like communities of people around specific things, like certain programming languages or certain topics. There's a lot of different machine learning focused servers on Discord. There's a lot of different servers for specific programming languages like Python and Mojo and Rust and so on. So I definitely recommend those as resources. But yeah, while networking can sometimes can be important for different reasons, I think it's nice to simultaneously develop the skill of being able to convey the nuances of your expertise from the get-go, to sort of reduce the importance of needing to have networked, but then also simultaneously networking to give people some real-world understanding of what it is that you do best.
Thank you, Sahaj. That was such an important question.
Hi, Tanmay. I am Adir. I am currently a CS undergraduate student, and I'm currently residing in Bangalore, India. I am actually the same age as yours, but seeing how you have progressed through your life, you have taken a very different approach as opposed to a traditional approach. That is, you go through school, you go through your college, and especially in India, you go through a CS engineering degree, and that's the norm everywhere as well. What intrigued me about you is your approach towards learning is very different. And my question to you regarding that would be, what principles do you think you applied in self-learning that most people, while approaching self-learning, don't, especially when it comes to tech? What do you think you did early on which separated you from the rest in your approach?
I mean, first of all, thank you. I think there's definitely different styles that work for different people. I don't necessarily think that the way that I did it is necessarily the right way. Like, different people will learn and become more effective through different methods of learning, for sure. But there are a couple of patterns, and then also one thing that enabled me to follow those patterns that I'll get to in just a moment, that I think would be really nice to sort of share to see if it works for more people. One of them is the fact that I had the luxury almost of time. Because I started working with the world of tech when I was 5, right? I had no deadline. I had no, I have an assignment due this day, I have an exam this other day, etc. I could say, I want to build this thing because it's interesting, and just start doing it and see where it goes. I've worked on many projects, even in the past couple months, where I'll start with an idea, start working towards it, but because I'm not married to it, because it's not an assignment or whatever, the actual idea and what I'm building itself will change throughout the process, just because I'm doing something interesting throughout the entire process. So I'd say that sort of luxury of time enabled me to learn through literal real world experience. Going back to what I said about actually feeling the pain of making the wrong decisions, it teaches you the common patterns that are necessary to building good software, and this applies really not just to software, to everything. And as a matter of fact, I remember, over the past couple of years, as I've had my friends themselves go through university, and I've seen some of their assignments, and I've seen some of their, quizzes and stuff. I've actually helped them with a couple different courses at some of universities and stuff like that, I've seen them, and they will ask me a question about something that their prof has told them, about a certain like architecture pattern maybe. And I will actually have no idea what that term means. And then they'll show me the assignment, and I'm like, oh, that. And it's like I just discovered that this was a way of doing things, but I never knew people had a term for that, or that's what they called it, because I didn't learn by saying, "Hey, what's like the dictionary definition of like the factory pattern for like software?" Right? Like it's not that. It's really understanding the core constructs and then composing them into patterns like a factory or something like that. And so it really does boil down to, once again, being able to take real world things that you build and experiences that you have, and being able to use them to take the core constructs that you discover you've composed, and learn how to sort of mentally map them in a way that allows you to intuitively think about how to apply them to problems. That's something that I find is hard to convey, because it's much easier to learn something by taking a course, almost literally, where, these are the patterns to follow, these are the tools to use, this is what these things do, here's the dictionary definitions of them, I'm going to follow that and use them to solve problems. Keep in mind that, treat even school, basically treat school or courses, things like this, not necessarily as the guideline of what to do, but instead the examples of how you might do things, and then use those examples to build your own mental model of why that might be a good way to do things, and then figure out how to do things in the future to build novel solutions. That, I think, is the way to approach thinking about learning. And when you think about learning that way, I find that you will end up learning more effectively in ways that are more generalizable to new kinds of problems. And that's something that I find a lot of people only realize after not just going through school, but then also getting a couple years of industry experience and realizing, oh, wait, the stuff I learned in school was just like examples, not actually like necessities, right? So if you sort of force yourself to use that mindset in the beginning, I find it's usually a lot more effective for real world software. But it's sort of going back to why I was able to apply that. It's not just the luxury of time and the fact that I didn't have like a school telling me to do things immediately, but also the fact that I had the right sort of support for me to be able to go through that journey. Like my family, for example, they supported me heavily throughout this whole process to enable me to put in that hard work to learn about the world of tech, right? Like for example, I say that it's really important to be perseverant, right? Like a roadblock is just a roadblock. It's not an obstacle. It's not going to stop you from achieving your goals. But at the same time, I wouldn't have been able to persevere through a lot of the challenges that I faced if it weren't for my family giving me the resources and the support necessary to do that. Like for example, when my parents made the decision to finally homeschool me, that was something that I was definitely really excited about. And it's something we had been discussing for a long time, but that's something that requires a lot of involvement and a lot of like working together and collaboration to make effective. And again, it's different for everybody. So without that sort of encouragement and that sort of like drive behind the scenes, none of this would have been possible. And so I think it is also the responsibility of folks in the community generally, teachers, educators, parents, and so on, to even just give students sort of like that sort of sampling, the experience to be able to sample across a bunch of different domains. I was talking before about how it's important to try a bunch of different, areas of software or technology or any domain to find what you're passionate about. So it's nice to have the resources and the support necessary to be able to sample across all those different little domains. So really, I think it's about the support that you get from the community and folks around you, and also really being able to persevere and reframe learning as not learning to apply what you learn, but learning why what you're learning works, and then being able to apply it. I think that reframe is really important, and is something that, again, even for me, is something I only really realized after a few years of experience, and sort of noticing how it is that I learn, which is weird because it's kind of meta in that way.
Yeah, that's totally understandable. Even though even I had the same experience, 2 years of learning, nothing replaces experience.
Mhm.
That is the fact for every industry out there.
Yep.
Also, one more question that I had in mind was, especially for a fresher like me, you are at a position where you do hire people for teams for developing software. So my one question would be, what is one thing you've noticed in candidates, especially freshers, that most freshers think are not as important, but it's visible in the interview that they're not good at it, or there's something that they're lacking, but they're not aware about?
Mm.
It's very common and not very well known.
There's an answer I have to this question, but I could be biased. And the answer I would have is I find there are a lot of cases where an interview doesn't go as well as it could have, only because the interviewee or the candidate was overthinking it. And I know that sounds sort of like cliche almost, but I mean that almost literally. Like there are some cases where within like 2 minutes of the interview starting, I can instantly tell that the candidate is taking it a bit too formally almost, where they're sort of thinking that I'm judging them a lot more harshly than I actually am, because effectively what I want all candidates to keep in mind is that the recruiter's not working against them. The recruiter's trying to work with them because the recruiter's goal is to get someone on their team that is really good at what they do, and would be effective at helping solve problems. Like I want to hire you. I don't want to not hire you. It would actually make my job a lot easier if I could hire you because that means I don't need to do more
Mhm.
interviews. And so I think
Exactly.
if anything, I'm hoping for the best with every interview. And so keep in mind as a candidate that the recruiter's working with you. Most likely they want you to succeed. And keeping that in mind, I think helps calm the nerves down a little bit and helps you not overthink it as much and keep the discussion more casual. Obviously, I think that this is more case by case. There are some situations where it might make more sense to be a bit more formal, but I like to sort of keep my interviews generally very unstructured, very, share your screen, Google things if you need to. I've even allowed people to use ChatGPT interviews before, as long as I can see what they're asking it and see that they're still solving the problem and they're using it for more specific things. It's totally fine with me because in the real world, you'll do that anyway. And so I think keeping in mind that your goal should be to really just genuinely get across what it is that you like to do, what experiences you've had, and to get their feedback and to sort of like go from there. I think trying to approach it with a level of being genuine and trying to showcase the passion instead of showcasing expertise is the best way to do it. Like I remember the last person that we decided to hire on our team. I remember speaking with them, and just immediately within minutes, it's very obvious that this person is just loves what they do. And I had actually gone through this the whole interview, and it actually went quite well. And towards the end, I just asked them like from this conversation, it feels like you would be the kind of developer to enjoy writing code in like Rust, for example. Is that the case? And they responded that while they don't currently code in Rust, they had just recently read a whole book on like concurrency code in Rust, which is actually even funnier because they don't even code in Rust, but still they're reading a book on writing concurrency code in Rust just because it's interesting, right? And so that I was partially right with my guess, and so that sort of like genuine interest, curiosity, passion that is very evident to the right interviewers, I find. So try not to necessarily formally showcase expertise. Try instead to more casually and formally showcase passion. I think that comes across a lot more in a lot more of a genuine way, and makes me feel like you would actually be able to adapt to a lot of the different like work that we do more easily, more readily. So I think that's probably the number one tip I give is don't stress it too much, but there's nuance. Keep it a bit more informal, casual. It's really all about sharing what you genuinely know and are passionate about.
I exactly, totally get that because in the current scenario, people are a lot more pressured than it used to be because of the competition inside the industry.
Right.
People overthink about it a lot and tend to mess up in interviews due to this. And so far, the answers you have given is like a wave of fresh air. After a very long time, I've been able to kind of resolve many doubts I had in mind through the questions other people asked. It's been great having you here. Thank you
Thank
very
you
much
very
for
much.
your time.
Thank you.
Hello, Tanmay. My name is Ayurda. I'm a grade 12 student who lives in New Jersey, US. And my first question would be, do you think AI can become part of our society like any other kind of human with its own unique identity?
I think I think this goes back to we discussed a little bit about being able to, I guess, give AI identity in society, and to sort of extend upon my thoughts there. I think while I don't believe that AI technology as it exists today will necessarily have an identity in the human sense, I think that we will start to subconsciously perceive it as a utility. You know, a little while ago, I had a discussion with UX Magazine. They have a podcast around conversational AI, and it's hosted by two of some of the like leading experts on conversational AI, and they've been in the field for decades. And one of the points that I brought up that they specifically mentioned was really interesting from a psychological standpoint was the fact that the people today, especially like older people today, have lived in a world where for many, many years, the only things that could use like language, for example, are humans, only people. And in fact, our brains have evolved for thousands of years in a world where the only things that can use language are people. And suddenly, they've just instantaneously been exposed with the release of ChatGPT to a world where now computers can also have high fidelity language interactions with you, and especially with like for example GPT voice mode, right? Like it genuinely feels like you're talking to a person. It can laugh, it can mimic your voice, it can do all these things, and so it gives you that sort of perception. But at the same time, if you think about folks that are really really young, like quite literally in the single digit ages, you know, under 5 sort of thing, they are now growing up in a world where this is normal, where this is just technology that exists, and that is a thing they've grown up with. And I think it's really, really interesting to see how in the next couple of years, I think the perception around how we even talk about technology will change. For example, from a linguistic psychology standpoint, which I think is a really fascinating field, it's one of the things that I'm super interested in apart from tech. From a linguistic psychology standpoint, there's actually a surprisingly deep connection between what seem like arbitrary word choices. Like for example, when you anthropomorphize technology, and when we say things like, "Oh, my computer's not cooperating with me," when it's like frozen or something, right? When you say that, you might just write that off as like casually, yeah, to do. But at the end of the day, the reason you use that word is because subconsciously your brain has linked the computer as also being human-like, or like, you know, sort of like an animal. In fact, I believe that doing brain scans on people as they use technology proves that they treat, again, at the subconscious level, interacting with a computer the same way as interacting with a pet or another person, right? And so like your brain makes that connection. So I'm curious to see as, you know, the years go by here, assuming that my prediction of machine learning technology as it is today not resulting in AGI holds true. So assuming that you know assumption holds true, I think it'll be fascinating to see if we maybe develop new language or new ways of describing the process of working with technology, working with computers, collaborating, quote unquote. See, I use a human word there again, right, with them, because we will suddenly sort of need to make the distinction between the kind of language and intelligence that computers use because there's no real intelligence behind it versus the kind that we use as humans, because now for the first time ever we've had to distinguish between two different kinds of language users. So I think there's a lot of interesting potential like possibilities of how that evolves. I don't think the AI technology itself will get an identity in the classic sense, but again, I think we will redefine how we perceive technology, or what an identity really means, which, you know, by today's definition might look like, yeah, we've given AI an identity in that sense. So I think there's the possibilities are definitely basically infinite. There's a lot of ways it could evolve, but that's generally what I predict is we will start to perceive technology differently and start to draw more of a line between it and humans, because we have to, because the capabilities are starting to get more and more similar.
Thank you so much for your answer. And my second question is, how can industrial design students like me prepare to stay relevant in an AI driven world? And what skills should I focus on now to combine creativity with AI efficiently?
Sure. I mean, I think one of the main sort of skills, first of all, I think the skills that I even shared for like software and so on generally do also apply to other domains like industrial design. But one of the things I may not have brought up yet that I think is also really important to keep in mind for industrial design, software, really any domain, honestly, is to start adopting AI tools now. Like one of the advantages that you have, especially being young and especially getting into the domain now as the AI tech itself is evolving, is you get to be at the forefront of the people who are in the domain and at the same time have the expertise of how to best and most productively use AI tools to help you be more productive in that domain. And so, for example, as you're learning, as you're gaining more experience, you are using these AI tools alongside your own expertise and your own intuition to help you be more productive, which means that you will be better at leveraging it to make yourself more productive than most. And that could potentially give you an edge in certain, subdomains of industrial design that maybe folks with more experience actually wouldn't have because they're more used to doing things manually and are less able to adapt to using this brand new class of tool to help them be more productive. So one of the things I'd say is adopt these tools, start getting used to them, and honestly, sometimes even use them when it may not be, well, even when you know, for example, that it won't be able to answer your questions. Again, going back to what I was saying about the abductive reasoning stuff, sometimes I will actually give GPT a question that I know it won't be able to answer just to see how it gets it wrong. Because seeing how it gets it wrong gives me a bit of insight into how it quote unquote thought. I don't like the fact that I use the word thought there again, anthropomorphizing, but how it thought about the problem. And that helps me build a better mental model for what kinds of problems to give it or how to structure those problems in the future when I have things that I know it could solve if I structured it the right way. So I think that's really an important one. But even just in general, going back to what I was saying before, it is still all about being able to gain real world experience quickly and being able to understand the core concepts of your domain. But overall, even in industrial design, as with software, I do think there will be a shift in like the definition of what it means to be an expert in the field. AI will definitely lower the barrier of entry to this field as well, and it'll make it so that people within the field are more productive at what they do, and you're able to crank out, more designs, solve more complex problems, and put more of your genuine individual human thought without AI to problems that do genuinely require creativity to be able to solve. There are a lot of really fun projects, both side projects that I'm working on myself, ones with my friends, and also at IBM. I think some of the most interesting ones are we are currently working on conversational agent technology at IBM, which is really exciting. Unfortunately, I can't talk too much about it just now, but there's going to be a lot of fun releases over the next couple months that I'm really looking forward to everyone seeing. Effectively, we are trying to scale the process of being able to build conversational agents that can automate and solve business problems. So integrating with tons of different business tools and being able to answer questions, retrieve information, perform tasks on your behalf using natural language interfaces, I think is a really powerful domain. Apart from that, of course, I'm currently working on a bunch of different new resources. For example, like on my YouTube channel, I recently published a new tutorial on the JAX machine learning framework, and I'm currently working on a whole new series of tutorials around ML and software in general, really, to help people get into ML from scratch and help them gain more experience. I'm also restarting one of my live series where I bring on students and different experts all the way from C-suite executives at different companies like Nielsen and IBM and Microsoft, all the way to as I mentioned, students and developers and so on. Bring them onto this show and ask them questions about their experience. Actually, build things with them live sometimes. So a lot of these new sort of forms of content, I'm restarting building those, which is a really exciting line of work. So definitely stay tuned for that. And apart from that, more generally, even just open source contributions and work in terms of building different machine learning models. For example, as I mentioned about the chess thing a little while ago, that's one of the things I will be publishing to my YouTube channel and also on GitHub soon, which I hope will be, from what I can tell, the most comprehensive and clear implementation of the AlphaZero algorithm, or at least the core concepts of the AlphaZero algorithm from Google, that will be available in open source. This is something that I'm actually kind of surprised doesn't exist already. Like the AlphaZero paper itself actually has a couple of mistakes in it's a little bit internally inconsistent, and so it was a bit painful for me to find out all the details. But I'm glad that I was able to figure most of that out, get a real like well documented open source solution out, and hopefully soon tutorial content as well. And apart from that, of course, keynotes, talks, workshops. I just got back this morning from a keynote and a workshop at Delta Hacks, which is one of Canada's largest hackathons held at McMaster University here. It was a really fun workshop. There were lots of interesting questions that folks asked about the world of ML. And of course, doing, sort of discussions like this one today, which I find really fun. And I'm looking forward to doing more of these sorts of things. So really scaling up more of what I do today already and continuing to do more of it. And that's what I find fun.
Tanmay, we can't thank you enough for your patience, insight, and enthusiasm with which you have answered all the questions today. So what I get from your conversation is if any of those present here, they want to learn machine language from scratch, they want to learn AI from scratch, they can follow your channel and you have tutorials there from which they can start. Am I right?
Absolutely.
Thank you so much for being a fantastic mentor and a role model. I hope so many of us have learned a lot.
Thank you very much. This was really exciting. I had fun during this discussion. There were a lot of interesting questions, and I'm looking forward to potentially discussing with you again in the future. And of course, feel free to reach out if there's any other questions I can answer or anything else we want to chat about.
Don't forget to like, share, and subscribe. And if you have an interesting story to share, or if you're a change maker, contact us.